Hi guys, this is 3.2. 3.3, 3.2 both are exponent laws. 3.3 is actually about the radical power, which requires a little more skills and a little more technique than 3.2, which are the basics. So today's lesson will be just based on the basics, and then we'll take one more day to finish up with the 3.3 in the next class, okay? So we're just going to be doing, instead of 5 rules, we're going to be doing 4 rules. As you can see, the fifth rule is the radical power. Don't worry, it's actually quite easy to do. So let's do the basics today. So 3.2, if you take a look at it, we have the multiplication rule for the exponents. Now, exponents will be added when you multiply two terms with the same basis. So in this case, the bases are the x's, right? And the powers are the a and b. So when you multiply those two, what you have to do is you basically add the powers. And now the reason behind it is, let's say, for example, if you multiply x squared by x to the power of 3, this is basically x times x and then times x times x times x, right? The first two represents the x squared, the later 3 represents the x cubed. If you then simplify this, we have 5 of the x multiplied together, so that is x to the power of 5. So if you look at the bases, instead of timesing bases, the exponents, the 2 and 3, we should add 2 and 3 to get to the 5. So that's the reason behind it, okay? So then all we have to do is just remember how to use the rule and then apply it. So we have the same bases, x and x, therefore, and the multiplication, therefore we add the powers as x to the power of 16. Now we have more terms, it doesn't really matter, we just do it one at a time, or you can do everything at the same time. We have 3 terms being multiplied together, and they are all bases of x, so we can keep the x as the base. And then we have all multiplication, and the powers are 10, 2, and then 3. All we have to do is just add all these 3. So that becomes then 10 to the power of 15. Okay, so it's not so bad, it's actually quite easy to do. Then the last one of the first rule, if you take a look at it, we have 2x cubed. Now, sometimes you may think that, oh, it's 2x, whereas the next one is 5x. They're not the same bases. Apparently, this is actually 2 times x cubed times 5 times x to the power of 11. So we can simply switch, right? We can simply switch the position of it so that it becomes 2 times 5 and then times x cubed times x to the power of 11. So I basically switched these two to terms location or position. And then it becomes 10 because 2 times 5 is 10. And then we have the same basis for the x's. So times x, and then we're timesing it. So it's to the power of 14. In a simpler way, it's basically 10 to the power of 14. This is a long way to explain why it becomes 10 to the power of 14. But in a shorter way, later on, all you can see is when you're multiplying 2 terms, all you have to do is multiply the coefficients together, okay? Coefficients together if there are numbers, and then multiply the other terms together. So in this case, then it will be 2 times 5, right? Which is then 10, and then x to the power of 14, because then you're multiplying these two x's, okay? So that was easy, okay, that was easy. Then let's take a look at the second rule. Now, second rule is the division, or quotient rule we say. Quotient P means that you're dividing. Now, when you were multiplying the same bases, you were adding the exponents, right? So, division, opposite of multiplication, therefore you subtract. So, then all we have to do is make sure the bases are the same, and then we basically subtract the powers. The second power from the first power, or the power right after the division sign from the one before that. So this then becomes x to the power of -3. Now we're going to deal with the negative powers later, so be patient with whatever that becomes for now, okay? Now the next one, same thing. So we have x and x and x. So x stays the same, then 12, 10, and then 5. Now it's division between 12 and 10, so it's subtraction, and then between 10 and 5, it's also division, so it's again a subtraction. So then this becomes x to the power of -3. Now next one, so we this time have coefficients. Again, coefficients always work with the coefficients. Okay, so let's take a look at the numerator first. Okay, let's just leave the denominator for now. So if you look at the numerator, it is 3x to the power of 4 times 6x, so that becomes 18, right? The coefficient by coefficient. And then x to the power of 5, because we have x to the power of 4 times x to the power of 1. If there is no power, that means it's a power of 1 all the time, right? Now, then we have division. The fraction is basically division, right? So don't get confused. Now, the same way as the multiplication, you just look at the coefficient by coefficient. So here the coefficient is 18 over 9. So it is then 2, okay? Or 2 over 1, but 2 is completely fine. Now then you look at the variable terms, or variable part of the terms. So then we have x, since the x is the base, and then 5 minus 10, so it is 2x to the power of negative 5, okay? So you look at the coefficients separately, you look at the variable parts separately, and then later you just put them together like before. Now, then the third rule is x to the power of a to the power of b. So here I didn't say x to the power of a times x to the power of b, I said it is x to the power of a times x to the power of b, okay? Now the reason behind this one's also same. Let's say I have x squared to the power of, cubed. Now this is basically x times x, or I can say this is x squared times x squared times x squared. Then this becomes x to the power of 6, right? Now, then instead of adding 2 and 3, it won't get to 6, which is the result here. So the only way that we can get to 6 using 2 and 3 is the multiplication, right? Well, you're going to say there may be different ways of getting it, but we're trying to find the simplest possible way to get to 6. So in this case is the multiplication. So when you have power to the power, okay, when the powers are right beside each other, it means you're multiplying the powers. So in this case, then we have x to the power of 4 to the power of 5, so that is x to the power of 20. Now, next one, we have x cubed times x to the power of 4 to the power of 2, or the square. Remember, the bedmess still applies here, so we have to take care of what's inside of the brackets. So what's inside of the brackets is x cubed times x to the power of 4. So that part becomes x to the power of 7. Then we have x to the power of 7 by, or x to the power of 7 to the power of 2. So I say x to the power of 14 because you're multiplying the powers, right? Because you have power to the power. Now, next one is slightly more complicated, but it's okay. Let's take care of what's inside of the brackets first using the bedmess, right? So the numerator becomes 8, x to the power of 5. Again, 2 times 4 gives me 8. And the x cubed times x squared gives me x to the power of 5, because you have to add the powers, right? Now then the bottom part becomes, it is 1 as the coefficient, so it will be 2, 1 times 2. And then x to the power of 9, because you are adding the powers since you're multiplying these two. And then squared. Now, then take a look at the inside of the brackets. So coefficient by coefficient, so 8 by 2, or 8 over 2, so that gives me 4. X to the power of 5 divided by x to the power of 9, x to the power of negative 4 squared. Now remember this actually means that it's x to the power of negative 4 times x to the power of 4x to the power of negative 4. So instead of this 2, the power of 2 being applied to the negative 4, it's also being applied to the 4 as well. So every single thing that you see. So then this becomes 4 squared, and the x to the power of negative 8, which is then 16 to the x to the power of negative 8. Okay? So be really careful of it. Now, then the next one is the negative power. Now, negative power basically means that you take the reciprocal of it, okay? Now, textbook or other things say x to the power of negative a is basically 1 over x to the power of a. But it's basically x to the power of negative a is x over 1 to the power of negative a, and then take the reciprocal of it, and then change the power to the positive. Then we have 1 over x to the power of a. Now, when you have power outside, it's always apply to every single thing inside. So the power of a is applied to 1, and then power of a also applied to the x. So this actually then becomes 1 over x to the power of a. That's why the textbook says x to the power of negative a is 1 over x to the power of a. It's not that you're just putting 1, okay? You're taking the reciprocal of it, so be really careful of it. Now, then let's take a look at the first one. So we have x to the power of negative 5. So change this to a positive power. We can say this is 1 over x to the power of 5, which is 1 over x to the power of 5, or 1 to the power of 5 too, but 1 to the power of 5 is just a 1. Now, next one, we have a fraction inside of the brackets. Now, then we have the negative power. So all we can do is we take the reciprocal of what's inside of the brackets and then change the power to the positive power. And then this square is applied to both 4 and 3. So this becomes 4 squared over 3 squared, and that's 16 over 9, okay? And then last one, so we have brackets, whatever that's inside, to the power of negative 2. Again, you cannot multiply these two directly, okay? Please don't do it. Just make sure you complete the inside first. Well, you can multiply this directly, it's just that it's a long process. So then we have 8 and then x to the power of 5. So hopefully you're used to it, right? 2 times 4 gives me 8, and the x cubed times x squared gives me x to the power of 5, and then to the power of negative 2. So this negative 2 applies to both of these. So it says then 8 to the power of negative 2, and then x to the power of negative 10. Now we can change that x to the power of negative 10 as well as 8 to the power of negative 2 into a positive power. Then we can say it is 1 over 64 times, the dot here means times, times x, 1 over x to the power of 10. In a simpler way, it can be just 1 over 64 x to the power of 10. So this is one way. Another way is then this. I'm going to write it here. So, or you can say it is 8x to the power of 5 to the power of negative 2. This simply, I'm just going to move this. This simply is then there we go. So we can say it's 8x to the power of 5 to the power of negative 2. This basically means that it's 1 over 8, the reciprocal of it, 1 over 8x to the power of 5 to the power of 2. So that then becomes 1 squared over 64 to the power of 10, which is then just 1 over 64x to the power of 10. Okay, so hopefully this was okay. Okay, hopefully this was okay. And then we discussed that y equals a times b to the power of x. The generic form of the exponential function is decreasing function when this happens. That's because if you have, let's say, y equals 1 over 2 to the power of x. Well, 1 over 2 is 2 to the power of negative 1. You can reverse it, right? 2 to the power of negative 1 then is 1 over 2 to the power of 1, which is 1 over 2, and then to the power of x. Now, if you see it, then we have to the power negative 1 to the power of x. So the powers are right beside each other, so we can multiply the powers. So it becomes x, becomes negative x. Now, remember that 2 to the power of x looks like this, right? Now, using the transformation that we learned in the last unit, whatever the negative sign that's applied directly to the x does the horizontal reflection. So 2 to the power of negative x then is the horizontal reflection of this graph. So that's why it looks like this as well. So this is another reason why it looks like it, okay? So hopefully you guys get this part. So hopefully you guys are okay with these 4 rules, and then you will practice it. I will post the questions on the Facebook, okay? So see you guys in class. Bye.